Okay, hey everyone, let's see if it works, if I can hear myself. It seems I can hear myself, therefore you should be able to hear me as well. Okay, so the messages on chat suggest that you can actually hear me, so we can get started. So first of all, hi, I'm Gunveil Coldwind, and as you can plainly see, I do not speak English as a native language, so, well, this is what you should expect of the stream. Anyway, I'm, like, why am I streaming? I basically already did a couple of streams in my native language, which is Polish, on both on live coding, then on Twitch, and then on YouTube. I don't know, maybe like 10 streams altogether on various topics. And, well, a couple of people said that, well, we actually watched the streams, but we cannot speak Polish, so why are you doing this to us? So, well, I got convinced and wanted to try streaming in English as well. So let's see how it goes. Basically, the stream will be about 2 hours with a break in the middle, which will be like 10 minutes, maybe. And it will be about trying to crack me, which I created for a capture the flag competition. Yeah, but I will get to that. Anyway, so I don't know, a few words about myself. I am the captain of Dragon Sector, which is one of the CTF teams out there. We tend to be like around top 3, I would say, in the world for in the last 3 years. So we're kind of out there. Anyway, apart from that, I work for Google as an information security engineer. Before that, I worked at HISPASec, which you might know from Virus Total. I did a couple of different things that were ranging from pen testing to malware analysis to coding to other stuff. And before that, I worked for a Polish antivirus company. Anyway, so so let's get this going. First of all, two more things. First of all, I would like to thank Krzaku, who is the moderator today. He will be on the chat. His nickname is like this, KRZAQ. You actually say it Krzaku in Polish. So if you have any question for me, then please type to this person on the chat, on the live coding chat, and he will tell me that, hey, again, there's a question. You should actually take a look and answer it. So feel free to ask any questions during, well, all the time. So thank you for being here, Krzaku, and for, well, spending your time doing this. You can visit his page, which is dev.krzaku.cc, and he actually has some pretty cool stuff where he's really into C++. So if you're into C++, you should visit his site. The second person I would like to thank is the Nervous Test Pilot, which you heard his music at the beginning. You'll hear it during the break, and you'll hear it at the end. He actually allowed me to use his music, so thanks. And I greatly recommend his music. It's actually the thing I listen to when I'm coding. There's usually no vocal, only music itself, so it's not disturbing. If I like listen to Iron Maiden or something, I sing along with them, which is annoying to my coworkers, so I tend to not listen to anything with vocals, so his music is just perfect for it. You might actually know it from a couple of games like Frozen Synapse, which is pretty cool as well. Okay, and the last thing is, well, actually, the last thing is getting the crack me, which we are going to crack today. If you go to my blog, which is gunveil.coldwind.pl, and you click here on the English side of a mirror, as I like to call it, you go to the second post, and it's called like Sources of ReRe. I didn't like the name of the challenge is funny because like I didn't have an idea for a challenge, but we had to figure out names to create repositories when we were creating the CTF. And this is, like I said, okay, so I'm doing a reverse engineering challenge, so let's just call it ReRe. Yeah, naming is hard, as you know. So this is it, and you can download it here, and I will show you how it works. So as I mentioned on, well, here and there, I actually did create this challenge, which means I am aware of what's the trick behind it, how does it work, and all the internals. That being said, I did not test it. I did not try to solve it at all. I created it with a couple of assumptions which if implemented correctly, I knew that this will work and the crack me will work and there will be no mistakes. So it's kind of risking here, but I think I got it right in the end. So I never tried to solve it myself. That being said, I am aware of a couple of solutions that people who actually solved this challenge during the CTFs, and there were like 5 people, 5 teams got it. So I kind of know how they approached it, and I'm going to maybe use their own approach, or maybe I'm going to use my own approach. I'll see that. Okay, so it's already downloaded. Let me. While I'm trying to find the files on my hard drive, I'm going to tell you one more thing. I'm using Windows 10 as my main operating system. But I'm also using a Linux virtual machine and a Windows X server. So that means that this is like my Windows console, right? But if I type here, and I'm in like B-Stream live coding ReRe, and this thing is already here. But if I type, LCMD, I'm actually spawning a Linux console. And if I do pwd, I'm in the exact same spot, in the exact same directory. It's really useful for CTFs because you get like best of both worlds. So, well, if you believe there's anything good in Windows, I actually do use it and I do like it. So I prefer Windows for like window management and other stuff, but Linux has a couple of great features like for example, mounting file systems of various types. On Windows, you can mount only like, I don't know, maybe 2 types, 3 types, maybe 5. But on Linux, it's like dozens of them, basically. So super useful on CTFs. Anyway, so my crack me actually, let me just unzip it. And there are a couple of directories here. Now we are only going to look at the, I think I went to the wrong directory there, but never mind. Yeah. There are a couple of directories here, but I'm only going to look at this, at the crack me directory. Spoiler alert, if you look at solutions.md, you are actually going to read the solution, and if you're going to read this, look in the source directory, you will read the source. So don't go there, go only in the crack me directory unless you want to actually see how it was created. Now, as you can see, the file is kind of large, it's like 556 kilobytes. So let's see how it looks like. Actually, before we see how it looks like, I'm going to start it. Now, funny thing is, I'm actually using an alternative. Well, it's right. Like I wanted to say like console emulator, but that's not true. It's somewhat a console emulator which works on top of the ConHost, Windows ConHost emulator. So. And my crack me doesn't really work well with it, so I'm going to start a console here like a normal Windows one, like this is a normal Windows one. Am I still in the same directory? Yes, I am. Perfect. And this works well with my crack me. I just need to change the window size a little and start it. Yeah. So this is my crack me and how it looks on Windows. You can actually type here stuff. Yeah. And this is where the flag should go, right? And some interesting messages go, downstairs over here. Let me spawn again the Linux console. It actually works on Linux as well. When I was creating this challenge, like most of the time I spent on making it actually work both on Windows and on Linux with like beautiful colors. So as you can see, the colors are a little different because like the Windows console and the Linux console work in a little different way. On Windows, you have only 16 colors, but you can redefine them. You can like choose any color from 16 million, palette color, basically, palette of colors. On Linux, you have, I think like 256 colors, but predefined. So it's like 2 different worlds, but in the end, I got it working with one code, basically. So it works here and here, and now let's see how it looks like. Anyway, just to be sure to, if you have any questions, again, then please let Krzaku know, and he will let me know. So otherwise, I'm not really looking at the chat, I'm trying to focus, so I might miss your questions. Sorry if I do miss them. But if you type Krzaku, which is like this, and then your question, he will let me know because I hear him. We're on like a voice chat, and that will work. Now, okay, so how does this crack me look like? I wanted to launch it in Vim. I actually use Vim, but let's start with this. This is like a viewer in from Total Commander. Total Commander is a great tool, which is one of the reasons I stick with Linux, with Windows. And I actually know that there are similar applications on Linux, but I don't know. I don't really never got a feel for them. So this is a crack me in Python, right? So this is Python code, which doesn't look too much like Python code, right? It's obfuscated, which is quite obvious. And I keep scrolling down now, and this is how it still looks like. It's like, yeah, a lot of obfuscation and absolutely no idea what's going on there. But I guess this is a little, well, it tells us quite a lot about what's going on here. As you can see, this stuff is probably Python bytecode, and what I did here, obviously, is I made Python bytecode and added some other arguments and created a custom code type, a custom object of that code type, and then made it into a function. So this actually created a function named underscore. And this is like an alternative form of creating a function in Python, which is obfuscated and we cannot read it. So one thing to do would be to actually get this bytecode, because this must be Python bytecode, and disassemble it, right? So let's try doing that. And what I'm going to do, I'm going to actually maybe copy this file. So I don't know, t1.py, naming is hard, right? So is ReRe the only challenge planned for today? Yes, it is probably the only challenge planned for today, because it will probably take me 2 hours to solve it, because it's like 500 points worth. That being said, if there is enough time, I might show one other challenge, which would be a 50-point reverse engineering challenge, which is a Linux binary. So if I have time, I will do it as well, but after this challenge. So okay, I did copy the file. Now there are a lot of functions here, like, well, actually only one, and it's called crack me. I'm going to remove it for the time being, and I'm going to focus on this thing, which is like Vim doesn't really want me to show it to you. And now we're going to disassemble it, and okay, another question, kind of unrelated, is there anything similar to JavaFX in Python? I actually have absolutely no idea what JavaFX is, so if you could elaborate, then maybe I am able to answer it. That being said, I don't know Python ecosystem too well. I actually like use vanilla Python with like Vim, as you can see, so I'm not sure if I can even answer that question. Okay, so how to disassemble it? Fortunately, this module, which is the disassembler module for Python, is already imported, so we're just going to do this, and the name of the function here, well, actually the reference, not reference, the, well, object pointing, what was it called? There was like a label, oh yeah, label pointing to the object, the function object here, and this should be able to disassemble it. So now let's run it. Okay. And let's see what's there. Okay, so we have some stuff here, right? It did output something, but as you can see, it crashed in the end. It said like index tuple out of range. This means like that the Python disassembler is not able to fully understand this bytecode, which is kind of weird, right? Because Python bytecode should be like straightforward. So what's happening here? Let's see what it did disassemble. Maybe we can make heads or tails out of this anyway. And what happened is that we see this jump absolute here, right? So related to the question about the binary, well, this is basically binary, it's just not x86, right? Anyway, so we have a jump absolute to this address, this actually, well, offset in the bytecode. So let's see what's there, and this is gibberish. It's like Python disassembler has no idea what this is, right? Like it cannot disassemble even this stuff. So let's ignore this for now, and let's just jump to 266 and see if anything we get lucky there. So we got kind of unlucky, as you can see, because what happened here, right, is that it didn't start to disassemble from 266, it started from 6.7, and then it got kinda ugly, so that's not good. So let's maybe do a little trick here and try to disassemble from there, but let's do it like this maybe. This is a string, right? So let's copy this string. Let's call it bytecode, because why not? Okay. Yeah, so Vim doesn't really like really long lines. That's my, at least the version I have. Sorry, I need to move another window to make sure I can see what you can see. Okay, this is better. Let's have this off screen maybe, just for Vim, because otherwise Vim is lagging for me for some reason. Come on, stop lagging, stop lagging. No, seriously, I'm going to restart Vim. Yeah. Okay, now it's off screen. So, come on. I think Vim doesn't really love that long string for me for some reason. Let's do it in another way. Then I'm going to copy paste it to another file. I'm going to call the file bytecode.py. And then I'm going to just import it. Then I won't have the super long line here, and Python will not be complaining. From bytecode, import bytecode. Yeah, sorry. Now, what I'm going to do is I'm going to actually find what's the no operation opcode in Python. I'm going to fill the first 266 bytes of the bytecode with that, and then I'm going to run it through the disassembler, so maybe that will work. Python bytecode. Let's see what we can find on Google about it. Here are some... there is some stuff here like the... Yeah, nope, this is what I'm looking for. And how do I find the number of knob? Well, I guess there are a couple of ways. Probably this. Let's see if this module has it somehow accessible. Yeah, there is like op map and op name. What is it? This.op map. Perfect. This is exactly what I'm looking for, and I'm looking for knob, right? And it tells me that is 9. It's just 9. So I'm going to do something like this. Bytecode is equal to 9. Sorry, that's like, it should be binary 9, obviously. So yeah, times 266, and I'm going to concatenate this with bytecode, but starting from this. I actually might want to like leave the first jump there as well, but I'm going to just do it. And then I'm going to disassemble it again and see what happens. So let's see what happens there. Okay. It still doesn't like me. Why do you not like me? Sorry, yeah, it's still this line. But it didn't output anything, which I'm not really happy about. Why didn't... Okay, that's not really good. That's not good. So what we can do is I actually keep a directory on my hard drive with like sources of stuff, and one thing is I have the source of Python, but actually before I get there, I'm going to take a look how does the disassembler work and maybe modify it a little. So which Python am I using anyway? I think it's yeah, so I'm using Python, exactly. I'm actually going to snatch this file from there, and I'm going to copy it here. And let's see how it works. Blah, 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 where do we crash? Maybe we can modify it a little to at least force it to output something, right, before it crashes. It did crash here. So it's complaining, sorry. Oh, okay, thank you, Im, thank you on the chat. Actually, it's a stupid typo, so it might work. And after all, yeah, it does work. Thank you. It works a little. You have to probably modify it after all anyway. Okay, so it got here, right? And what we can see is jump forward, and then it jumps like here. It just jumps here. And then we have get attribute, which is just like a string, and it loads it onto the stack because Python internally is just like a stack machine, right? Then it jumps forward to 81, and I don't know, it's a little doesn't make any sense here at all. So let's just jump over it to wherever it tells us to jump. So to do it, I'm going to modify it a little again, and this time I'm going to tell it to jump to this. Sorry, not to jump, to like yeah, I'm going to like put some no operations there as well, because let's ignore these instructions at this moment. Maybe we these two, maybe we'll have to come back to them later, but not yet. And this is 281. I am currently at 278, so that's what, like 3, right? If I count correctly. And we do something like this again. And okay, and it got a little better. So I knocked something out, then it loads another thing, and some constant, and then it jumps forward to this, and then there is a okay. So there's a clear pattern here, as you can see. Like after every, well, maybe not every, but there was a jump forward here, and there's a jump forward here, and then there was like 3 bytes of like nothing really important. So like that's just garbage, right? And there is like garbage again here, because this is like another 3 bytes, like 1 opcode and 2 bytes of an argument, and this is an address which is doesn't matter. And then let's see here. So this is another jump. It jumps only, well, it jumps quite a lot of bytes in front, but then there is again like this doesn't make any sense. No, I'm not correct. It actually jumps like 3-4 bytes again, and then the same. So this is like some form of obfuscation. We can make these jump forwards. We can just remove them. The ones which have like really short jumps. Okay, so Kshaku says there's another question. Why do you struggle with this? Why don't you use some different tool library? Maybe this is the purpose of the show. So I'm struggling with this because, as I said, since I created the challenge but I never solved it well, I kind of know what to expect, and I kind of know that struggling with this is one of the ways to go after it. That being said, I'm pretty sure I'm going to have to write my own disassembler at some point, or I'm going to have to, if I would be using another tool, another library, I'd have to do the same, but I'm more familiar with this code, so yeah, so that's why I'm sticking with it for now. Also, in all honesty, I don't know of a better disassembling library for Python. If you know any tool or library to disassemble Python bytecode, please put it on chat. I'm actually curious myself, so let me know. Okay, so let's get going. How am I going to solve this problem? Well, I'm going to check what's the bytecode of... where is my console? Is this my console? But it's not the one I wanted. Yeah, this is. I'm actually going to run Python again and see what's the opcode of jump forward. So import this, and it was this .opmap, if I remember correctly. Yeah, jump. Okay, it's 110, so I'm going to look for 110, then I'm going to look for the argument, and if the argument is like a couple of instructions in front, then I'm going to knock out everything, including this jump forward. So let's do it like this. I'm going to actually do it on this string. Yeah, on this string maybe. I'm also going to check if the value is kind of sane for the jump forward argument. Actually, maybe going to use this. Because I have this already imported, so why not? Okay, so for how do we go about it? I can actually create a byte array here. I think that will be easiest, because like strings are not really mutable in Python, but if I cast it to a byte array, it should be fine. I should be able to work on it. Now let's just do a while. Could I do a for? Maybe I could do a for instead. So let's do a for, and I need an index and I need a character. Let's call it B maybe for byte in numerate spelling. Okay, perfect. And if B is equal to JF, which is jump forward, then something, but I'm actually going to do a reverse thing, and I'm going to continue here. Now, since I'm going for this solution, then I need to do something more, which is, okay, let's not go too far in front. So if it's actually a jump forward, then I need to get its argument, and its argument I actually need to decode it, so I need to import yeah, these two things, which is pack and unpack, so I can unpack the argument, and I can do it like this. I don't remember if Python is little or big endian, but I'm going to assume it's just little endian or like native endian. I'm pretty sure it is, because there would be like no reason to slow this down. And H is for like unsigned half word, or should it be maybe a little h, so it's also accepts like negative numbers, right? I plus 1, I plus 3, so we get 2 bytes for it, and 0, because unpack actually returns a tuple, always a tuple, so I need to first think of it, and let's see if it works first, and then I'm going to actually do something about it. So when I'm typing stuff like this, I tend to, well, I would say over-test it, especially when I'm doing it on streams. Well, this is 2, right? I would say it's 2. Oh, but it expects a string. Well, okay, I can give you a string if you're so insistent. I have absolutely no idea what I'm saying here. Oh, here it also expects a string, I guess, on the bytecode, and I did make a byte array out of it. Okay, 3, okay, 3 and 0, these are the arguments, which is fine. I'm actually not sure if I should start from here. Actually, I should do something like this. If I is less than 266, then actually just continue, because I want to ignore the first part of the bytecode, right? Now, what I'm actually going after in the end is I need to de-obfuscate this bytecode to understand what's going on, and after I have that, then I can maybe I'm able to understand better what's going on here, right? Okay, so I have arguments, and if I have arguments, I can check if the argument is, first of all, it needs to be, well, at least 0, it needs to be positive. And it has to be like a sane value. And by sane value, I mean, I don't know, let's say 10. 10 seems sane-ish. I kinda am afraid that I will override some jumps which are actually meaningful and not a part of obfuscation, but if that happens, then I'll deal with that later. Sorry. Okay, so there's a question. Can I send you a really simple question about studies on your YouTube account? I would be grateful. Like studies if you mean university. Yeah, sure, go ahead. Send it. I usually reply to both emails and like YouTube messages and so on, but it's best to send me an email if you need to ask a question, because like off stream, obviously, because I do check and reply to emails, and when it comes to like YouTube messages and so on, I check them only so often, so I might miss it. Okay, so if this is the case, no, I'm actually going to go for a reverse again. So if this is not the case, then continue. So I don't have too many, indentation levels. And if it is the case, then just yeah. So since I'm running in F4, I need to like switch into overwriting with nopes mode. Okay. So if I'm in this nop overwriting mode, then I'm actually going to assume this is an integer. I will set it to be an integer, and if this is now 0, that's fine. I can set it to 0 here to not switch between two different types. It doesn't matter in Python, right? But just to like keep one type for the variable. Yeah. Which is not our operation. Okay, now I'm overwriting everything until it's 0, and I need to continue here. So, okay, and I can put this to whatever the argument is. So, okay, but I'm actually not sure. Is the argument to this... The argument to this is calculated probably from the point where the instruction ends, or maybe the point... I don't know. What's in the argument? So let's see, it actually should find these two jumps, right? So jump forward 3, which is to this address. Okay, so this is kind of funny, right? Because if I do like a subtraction here, I'm going to get 6, which means that for like this instruction plus its arguments is like 3 bytes, and therefore the argument is like how far to jump from the end, from the next instruction. So it's like basically like an x86, if you're familiar with how jumps work there. Which means what can I do here? What must I do here? This is not my code, this is my code. So I'm going to overwrite, starting actually from the point where I am. So I'm going to overwrite already 1 byte because I'm going to ignore this jump. Am I going to ignore this jump? Yes, I'm going to ignore this jump. And then I'm going to do whatever the argument is, and I'm going to add 2, and this should actually work enough for me, and let's see if it works. So, I don't know, did it work? Did it somewhat work? I think it does work, but I need to remove this, yeah. And it doesn't like me because probably the last instruction or something is Shaku says that there's a question if I'm famous. I don't know if I'm famous or anything. It's probably I don't know, good marketing or something, or somebody famous retweeted my tweet. Because yeah, the view count is quite nice. So hi everyone, thanks for joining. Anyway, well, it crashes now here, right? Because it's like it reaches the end of the buffer and still tries to read behind it. So what I need to do here is I need to actually make sure that I plus 3 is actually less than length. Well, if it's more or equal to length of my bytecode, then I need to bail out early. So do something like this, and let's see if it works. So something did work. Did I make a mistake anywhere again? Tries to find labels. Maybe it tries to do a jump somewhere. Well, actually, I don't care that much. We can do something like this. So bytecode is equal to bytecode. We can like ignore totally what's at the end and go only so far, right? So, I can actually do here something like this. I don't know, maybe -1, and let's see what happens. Come on, it's like the second time I make this mistake today. Yeah, okay, now it works. Sorry about that. Whoa, quite a lot of knobs here. I really hope nothing important got removed from there. Okay, so let's see what we're looking at. Yeah, thanks again for pointing it out. Yeah, I guess you're the person today who says that like my semicolons are in the wrong place. Please continue doing so. What am I looking at here? Actually, what I'm looking at here is like the strings. I don't care about this side yet. I'm going to look at it later. First, I'm going to focus on the strings. The strings are actually, I could read them already, probably somewhere here. Where's my code? This is not my code again. This is my code. I could read them here. So let's, well, whatever. Let's go here. We have the code, the join, well, character, get attribute, as we said, true, func code, code, get size, cbyte, len, from address, okay, cbyte and from address. This is starting to get interested, right? I mean, everything, like, this is like normal stuff, probably. This is getting interesting, and this is weird. I mean, what does this function do in the end? Then we have some map, ort, set, and false, and then we have some variable names here. Here are basically variable names, right? So, okay. Let's see what happens here, like just going through, well, both, in this case, both things. So we have some state, like a global, we call a function, we call this function. Why are we calling this function? I think this is our function, right? Why we are calling ourselves. I don't know, but we are for some reason. Never mind. So it calls it, then it stores whatever the result is in state. And it loads the attribute, like func code of this. So, but that's funny, right? Because it like gets a reference basically to its own bytecode, well, function object in this case, and here is like bytecode. So it's a function which gets a reference to its own bytecode. So if you did reverse engineering, you probably see where this is going, right? So you're probably going to go after self-modifying code in Python, which is kind of funny and surprising, I would say. Then it gets the size of it. Then it calls some function, which is, well, it calls this function, right? Then it loads a constant, which is 15, and it subtracts something, stores it as an offset. Then this is a cbyte type, length, and whatever. From address, what does from address even do? I have absolutely no idea what does it do. And then we have ID. Let's start with chatting with the Python documentation. Bitcoin, that's probably not what I wanted to check. C-type reference. So is there like an official documentation which I can look at? I don't mind other pages, obviously, but... Okay, this method returns a C-type instance using the memory specified by the address, which must be integer. And then we have ID. So ID is a function in Python. Okay, so I'm not completely sure it's a function. It might be like an opcode or anything else. Let's actually check this out. Now let's use this console. What are your ID? You're a built-in function. Okay. And it, I don't know if you know, but it actually returns a pointer. And this is like, if I show this like in a hexadecimal way, like so hex, this is actually the address in memory of this string, of this object. So what ID does, it returns like a low-level address in memory where a given Python object resides, which is, in this case, is going to grab the... Well, we saw what it's going after, right? It's going after the bytecode of the function. So it grabs the memory, the location where the bytecode in memory is put. Then it calls this function, and then it loads the offset, which it's set to, I don't know, 15 or something like that previously. Okay, and then it does something like map or so okay, map is just like calling the function or in this case on an array, like on each element of the array. And this does a slice. Oh, there's a key, which is funny, and there's a size. So whatever happens here, it gets put in the key label. Basically, key label points to whatever this part calculated or derived, or whatever you want to call it. Now, size, it puts like 250 in the size, and then it creates a loop from here, starting here to 730, and then what happens then? It compares, so it's like probably a while or something like that. I'm just trying to basically figure out what's going on here just by not really analyzing the code, just by looking over the code. So if you're like just starting on CTFs and stuff like binary analysis, you might be a little lost here, and I apologize for that. But actually, with more experience, you can kinda derive what the code is doing without doing like a opcode by opcode analysis. Okay, so then it takes the key, it takes this, and it does a modulo with 13. So would 13 be the size of the key? It's actually pretty possible. Then, what's this? Binary subscript? I actually have no idea what this is. Is it like grabs? It's probably grabs. Like, I don't know, a byte. Oh, okay. Yeah, so, well, this is pretty much self-describing. It's just like grabbing from an array, from a list in this case, an item at the given position, an element, I guess would be the correct word. And then does XOR, and plays XOR. Okay, so this is like, you know, encryption 101, like basic obfuscation of binaries on x86, but it does it on Python bytecode instead. And yeah, and this is where the loop ends, actually. It like jumps to the beginning of the loop. So it's probably like decrypts. It somehow gets the key to the XOR and it decrypts the bytecode. Then it, oh, there's the set attribute, so it sets the state to something. And oh, there are quite a lot of like the stuff we removed, right? Quite a lot of it. Blah blah blah. And in the end it jumps to 16. So let's scroll back at the 16. Actually, there will be nothing at that part. I'm going to close this because we did remove it, right? So I'm going to write whatever this output is generated to, I don't know, t1 txt, and then I'm going to modify it a little to actually not remove the first byte of the bytecode. Okay, so like this, it will crash, but I don't mind it crashing. It didn't crash, which means I don't know. I didn't save it or something. Oh, it still does the de-obfuscation. Well, never mind. Unless it removed the. No, it didn't. Okay, so it does say that it starts the code from somewhere around here, right? It jumps to 16. So, well, we don't see 16 here, but it's somewhere around here, which leaves us to this. What is this? Because if it's not the code, right? As you saw at here, it jumps to address 16. It doesn't jump to address 3 for some reason, which would be where we expect the code. Now, another thing which we saw here earlier is that it does like some slicing, like slice plus 3. If I remember correctly, it's just like the implementation of, well, of this. Yeah, so you have a buffer, and then you have some values here, then this is slice plus 3, but we can actually, we can verify it here, build slice, C slice. Yeah, it's basically the same, right? So what does it slice out? This is the interesting part. So there's 16 and there's 3, which means what it does really, it does something like this: 3, 16, right? And here is probably just 1. I don't know why it's 3, but I'm assuming it's 1. This is a safe assumption. Maybe it's -1, but whatever. And then it uses this as a XOR key. And then it decrypts the function starting from, well, from 16, right? Up to whatever the first jump is at. The first jump is at this address. So let's try to decrypt it ourselves. What we have to do in this case is something like this. There are a couple of things here which I don't fully understand, but whatever, let's ignore it for now. I'm going to set I to 0. It might be like 3, it might be like 16 or whatever, so I don't know. This is 13, which is like in, well, it's the same what we found with the modulo operation somewhere here, right, in the loop. Okay, let's decrypt it and see what happens. It might not work for the first time. There might be some catch here, but let's assume, let's take it at face value for now. Okay. Actually need to verify the address. So there's a question if string is not null terminated. So I actually don't remember. I mean, so it's like this. In Python uses like on the surface, right? It uses the what's it called? Pascal strings, which means like you have the length of the string and then you have data, which means you do not need a terminator. That being said, internally Python might actually have the terminator at the end just for like the sake of it. Just when you like when the programmer would like to call some C function, so the Python doesn't have to add this terminator at the end. So I'm assuming that in the implementation of the string itself there is a null terminated, but it's not really needed on the Python level. Okay, so y is length minus whatever it starts, so 16. And bytecode, we XOR it with XOR key. Actually, I need to add 16 here, right? With I modulo 13. And let's see what this gives. Yeah, usually when I do this, I forget this little line. So it crashed, but let's see what happened. So, oh, okay. So, yeah, this is probably even correct, but the problem here is that we need to do something like this. We need to remove the key, basically. Because otherwise the disassembler just well, you see what happens, right? 9, which is, again, is not no operation. Okay, now what happened? Okay, so load fast. This isn't super bad, but again, yeah. This is the obfuscation, the same obfuscation again. So what we're going to do is we're going to remove this part. We're going to move this part actually to 16 as the code starts there, and let's see what happens. So it didn't crash, which is a good thing. And it again is like the function is really removed pieces of it, which is fine. And let's see what happens here. It does a decode. What does it decode with? Where's the argument for decode? I don't know. Well, maybe. Then it loads 99 and some other constants. Like this is ASCII value. Like, I mean printable ASCII value, because like any number obviously from 0 to 127 or 255 is an ASCII value, but this is actually like a printable range, and this is like probably lowercase. So let's see what is it. So it's like 98, 102, 105, 104, and we do, what do? We do something like this. Yeah, we basically decode it. BFIH. Or is it like from the back? Absolutely no idea, but there are some other letters later on, so let's... right? Correct? Yeah. I don't know. I mean, this doesn't look like anything. So let's see what goes on later. It builds a slice starting from -2. Does it? First of all, I'm not even sure if I have this in correct order. It does build the list, right? But does it build it like from the side I have or from the other side? It actually doesn't really matter. I shouldn't have pressed that. Now I need to scroll back. Okay. So okay, let's see. -2. What's -2? Oh, doesn't help me too much. What if I actually like flip this? If not perfect either. So 0, 0, -2. No, so I'm actually doing it wrong. 0, 0, -2 is like this. And that's probably not 0, it's probably like this. Okay, now we're getting somewhere. Z-lib. So it's like... oh, I'm sorry about it. I'm going to move it. Thanks. Okay, so it's zlib, and it does decode with zlib. Somebody tried, well, I tried to obfuscate the string. Honestly, I did not remember I did it. It was some time ago. And then it probably calls, like, decode somewhere here. Which is kind of funny. Does that mean that actually, like, because, so, okay, let's not get ahead or I will not get ahead of myself. Why does it do a for iteration here? So it grabs something, does this. Okay, I don't know, but this code is like actually super short. I wonder if like after this de-obfuscation, I could actually use a Python decompiler. That might be possible, but I don't really care too much about it at this point. Let's see the crackme file again. I have it open here, and as you can see, if I scroll down actually quite a lot, I did notice at the beginning, I hope you saw it too, that the underscore function is like called a lot with these funny strings. So maybe like if I take this string, like take this one for example, it's actually like zlib and I can decode it. So let's see if that is the case. So okay, I'm going to take the string and I'm going to do .decode and zlib. No. Okay, so there's one more catch probably somewhere here, but I'm pretty sure with the zlib part. Oh, okay. So this is kind of revealing. If you look at all these strings, they have like the end of them is like identical. In each case, there's always an X and there's always this. So let's do. Sorry, let's take this and let's do first rotate the string, like reverse the string. Perfect. So this is like all the strings are just reversed, and there's probably, if I would look deep enough in this code here, which I again scrolled over, there probably is like a reversing the string somewhere here, and then you decode it with zlib. So yeah, this seems to work. Yeah, it's finally English. Yeah, well, whatever you call whatever I'm speaking, let's call it English. Let's be polite to me, thank you, and call it English. So let's obfuscate all the strings. We already have algorithms, so we can do it. And after that, we might take a break. How many times is it called? Quite a lot of times. So let's do something like this. Let's do something quite. Let's actually overwrite it. I'm going to do another copy of this file. And I'm going to do copy. No, it's ReRe to t2.py. Okay, let's hope Vim doesn't complain too much about this being too long. I'm going to just remove this. Okay, now what I'm going to do, I'm actually not going to call this function in the end because this crackme function which is created here is called in the end. What I'm going to do is I'm going to define my own function like this, and I'm going to do two things. First of all, I'm going to just do what I did in my console a while ago, which is the code zlib, and then I'm going to print it because I like printing stuff, and then I'm going to just return. And this should give me a lot of strings. It gave me a lot of... Whoa, I can hear the bell sound in my headphones, which is not too good. Okay. And there are a lot of strings, which means we're getting somewhere. Okay, so Krzaku says there's another question. What clued you that it had to be rotated? So well, rotated, not really rotated, is like reversed, right? What clued me is like, if I look at each call of this function and at the end, there is this, right? It's like always the same. It's always the same characters here. Now, I actually know for a fact that zlib at the beginning has a header. And the header actually, it's not a magic string. There are a couple of options there and they need to follow a rule. But that being said, they are commonly like the most probable thing in zlib is that for the header to look like something, and so I figured like why is something constant in all the strings at the end of a string and not at the beginning of a string, which might mean that it's reversed, and it's super easy to do like reversing the string in Python, so I figured that it might be reversing. It didn't have to be reversing, obviously. It might be like anything, right? But it's always worth to try such things. If that wouldn't work, then I would just go back to analyzing the loop and see what it can tell me. Okay, but not rotated, again, reversed. So sorry for, it's like, I sometimes mix up words quite a lot, actually. So let's do it like this. Let's do 5 minutes break. My voice actually needs 5 minutes to break, of a break, and then we're going to take a look what did we find in the strings. We're going to take a look probably what is this thing, which doesn't look too readable. It's probably more obfuscated Python bytecode. And afterwards we can see if we can crack it. And we'll actually move it a little forward at least. Cracking is is still kind of out of reach. So yeah, I'm going to leave you with, I don't know, this. And see you in about 5 minutes, I would say. Let me put some music on. Okay, so it's time to get back to this. Now I need to do this and this, perfect. And I need to mute myself so I don't hear myself on live coding because it's kinda kinda disturbing. Okay, perfect. So okay, just a summary for whoever joined us or didn't watch the stream from the beginning. We're trying to crack me, and by this crack me I mean, sorry, I need to run it. Crack me, which looks like this, is a Python crack me, and it's heavily obfuscated. The main, let's see if I don't have it opened, but it actually looks like this. So quite a lot of bytecode, and actually like Python just, well, the code just creates, manually creates a code and a function object in Python. So it's basically like, and this, as it turned out, was a obfuscated Python bytecode, which got obfuscated by self-modifying code in a way where it took, well, the bytecode of this function, which is actually this, right? And then it this is like a jump, and it jumped somewhere here, right? And this part looked in memory at where was the address of this bytecode, of its own bytecode, and then took like these bytes, they were like the XOR key, and decrypted with XOR like the rest of the function, and then the last instruction was actually jump to the decrypted part, right? And then it executed. Now, what I didn't show, but what I actually know for a fact, is that when this function finishes, then it actually goes again through the encryption routine, and it encrypts the function again. So at the next call, it needs to be decrypted again. So there's like never a point in the code where the function is decrypted, apart from the moment where the function is executed, which might be actually a good thing for us, because we might have a way to dump the functions when they are executed, right? So, but that would be rather tricky to do, but we might try to do it, and if we don't find a better way. Anyway, so what we did, we reverse engineered this function, we de-obfuscated it, we reverse engineered it, and we know that this is actually like a string de-obfuscation routine, which boils down to this line, to one line, right? And I printed all the strings which are obfuscated this way, and let me maybe dump them to a text file. Okay. Well, Lister doesn't even think this is a text file. So there's like a lot of probably still obfuscated stuff here. Maybe it's like a, I don't know, double obfuscation or something, because I mean, this actually could be like double obfuscations, and then there are strings which I'm not sure how well you can see. Maybe I'm going to use this because this has a bigger font. And again, this function is probably used to de-obfuscate even more strings, right? So we can, you know what we're going to do? We're actually going to run this and see, but we're going to do it in a different way. We're going to run it, but we're going to, since, I mean, the crack me is obviously super graphical, right? Well, graphical in text mode, whatever. So we cannot redirect this to standard output. We better write it to a file. So let's just open a file called ASDF. Naming is hard, so I use funny names. That's normal for me. And we're going to append data to it, append the strings to it. And we're going to open it as F, and we're going to write the de-obfuscated string plus a new line. I'm not sure if this is faster than actually like, well, it doesn't matter. It's like not an optimizing competition anyway. So yeah, so let's just run it, and it works. And as I said, I actually have to run it in like a normal Windows console for it to look nice and all. But I do need to resize the window. Yeah. So it looks like this on Windows, but this is not the usual Windows console. This is ConEmu, which is based on PuTTY, and it doesn't like the application changing the palette color. It doesn't support it at all. So this is why you need to launch it in a Windows console, like the standard conhost thing. So it created a file, probably created a file. Did it create a file? Yes, it did, and it's 50K. So let me open the file. And I'm not interested in the things which are like here, right? Because this is the thing we already saw, so I'm more interested at the things which are at the end of it. Is there anything funny here? So okay, whatever. Yeah, so as you can see, there are like some Win API functions. Could you tell me on the chat if like the font is actually enough, if you can see it clearly, or should I make the font bigger? Okay, please make it bigger. Perfect, making it bigger then. How do you make it bigger? No, seriously, how do you make it bigger? Where's font size here? Yeah, sorry, like, oh, it's here a little. Yeah, let's do, maybe use this font. And now it should be visible. Okay, it's visible now. So again, let's look through the strings, because they might be fun. So again, we can see the same strings. It's like the same strings which are used to application. So there's was my Counter-Strike Go Global Offensive rank currently is Master Guardian 1. So it's like, yeah, the middle. There's some palette stuff. Some other stuff. Oh, MD5, this is funny. We can, and digest. We should see what this is used for, actually. Can we hack digest somehow to print whatever it's used for? How do we do it? So we probably should... so how will it work? How does this thing even get the functions? It probably calls import, right? Does it call import? There is, so it's actually quite funny in Python, because there is, when you actually do something like this, and here do import, I don't know, whatever, like import MD5, right? If you disassemble it, sorry, let me do this. If you disassemble it, it actually calls import name. But what happens really is that there's a built-in functions in globals. If we do globals, globals and built-ins, should probably use the other console. And we do a dir here. There is something here called __ import. Yeah, this. And this function is actually what's being called when you use this opcode. So we can try to do something like this. My import, maybe? Oh, it actually takes like a gazillion of arguments, if I remember correctly. Let's see. Let's consult with documentation. Okay, another question. Can you hook functions in Python? Well, that's what I'm... in the end, what I want to achieve. But I do need to start with hooking import, I believe, first. Oh, I think I could do it in another way even. Because all the time, I believe like this function is called. Well, I know this function is called, right? So no, I'm actually going to do something else. I'm going to do like a super funny hack here. I'm going to check what's in the globals, right? And if MD5 from hashlib, if hashlib gets into globals, then I'm going to like do something. I'm not going to write the strings anymore here. I'm going to write some debug messages later on. So let's do. Oh, we can do it in an even funnier way. Let's do it like this in a funny way. The funny way actually consists of if s equals to hashlib, then return hash not lib. Perfect. And hash not lib will be our hook, right? And we actually need to import hashlib for this. Yeah, so we do something like this. No, we actually do like no, even not like that. We should have a module called like hash not lib, which is funny. Hash not lib.py. I'm actually going to change this to lowercase. Yeah, there are a lot of ways to actually hook a function in Python. So as you can see, I'm kind of undecided which way to go in the end. But I'm going to go this way. Now I'm going to do this, and I'm going to do so I need to create my own thing, which is called MD5, right? And it's supposed to be a class, I believe. So I'm going to do class MD5, and it's going to use like the original one. And then I need like init. I'm going to do, well, as you can see, I'm doing class hooking, if you can tell it like that. Then it has some arguments, and it's probably going to be called with one argument, which is like the thing which is hash, because you don't see any update, any finals here, right? So it's going to be probably this invocation, and we want to know what it is, right? We don't care about anything else. For all we care, everything else can crash. So, but actually no. Actually, let's do something like this. So how do you? It's my memory. I don't remember. How do you call? I think you do this, and then init, and then self as to call actually the constructor. Or maybe I could use just hashlib.this, and this would work. It would work as well. Just in case it crashes in a funny way, I would like to flash it, and there's a digest. It might, well, whatever we entered might be validated here, obviously. We need probably one more thing here. Okay, let's do it now. Let's not do it like this. Let's do it like this. Probably easier. And I actually, so what I wanted to do is there's a neat trick in Python where you can actually like use special methods to redirect everything to another class, but I'm not going to do it. I'm going to like for this simple solution in the end. So yeah, it's like digest. It's not like hex digest. Okay, whatever. Plasma Power says, it turns out Vim is slow on long lines because of syntax highlighting. Try doing set synmax call to 120 to limit syntax highlighting. I am going to do it. Thank you. I did not know about it. Let's see if it works. Yeah, it works. So, and it seems to be quite fast. So thank you. Thank you. Okay, this should work now. Let's see what happens. It was called T2? Yeah, I'm still experimenting with T2, yeah. Okay, sweet. And I actually have no idea if anything happened. Because maybe I need to like just exit here. Let's just exit here. Is it sysexit or is it the operating system? Oh, okay. Python. Look, it looks like a flag, right? So let's copy it and let's enter it in the crackme and see if it works. Obviously, I cannot copy this in a simple way. Okay. Oh, nothing happens and I still can type a couple of things. Yeah, so this is actually a thing I got a lot of questions during the CTF. I'm actually, I kind of like trolling in my challenges, so this is not the real flag, obviously, and but it was like, if I remember correctly, I used MD5 just for this, just to like people can find a fake flag, but it's a fake flag. That being said, it's still not a worthless exercise in the end because we now know exactly that we can interact with it dynamically and we can hook whatever we want. So, well, at least a class here, in this case, on a module. So we can use this method to see well the state of the application in other places, and see what happens. Oh, sorry. Let's see what are some of the other strings here. Find nearest RGB palette overflow. That's funny. Yeah. if I would look further, I would find the fake flag anyway. So well. sans serif monospace. Why does it have a font name in a console application? This is weird. Oh, look. This is actually the text which is displayed here. We can read it. So let's go through it without waiting. So, hello there and welcome to another Python Crack Me made by Gunveil. This one is worth a lot of points and it might or might not be easy to solve. Scrolling text is fun, isn't it? Terminals are tricky, especially if your code is supposed to work both on Windows and Unix-like systems. Did you know that Xterm compatible consoles have 256 predefined colors, but Windows standard console has 16 modifiable colors? Oh, and if you're looking at this Crack Me via Conemu, or a similar console emulator, you're missing out. It doesn't support palette modifications on Windows for some reason. Did you know that Windows 10 has a conhost v2 which implements some terminal escape functions? Well, escape sequences. This is actually true. So you can do ASCII escape codes again on Windows. Perfect. Yes, they brought it back. Isn't it wonderful? By the way, why are you still reading this text instead of trying to solve the Crack Me? This is actually an excellent question. No, there are no hints in this text, it's just here to keep you distracted. Hint. I've already told you there are no hints, go away. Or maybe you would like to read this text again and restarting. So yeah, no clues here, no hints here. Let's keep moving upward. This is like probably another function name. Well, you can see like there was quite a lot of thought behind the simple like palette cycling here. Find nearest RGB. Yeah, quite a lot of stuff here. So the key is obviously for the obfuscation. What I would need is actually something else. Change console mode. Everything is like for graphics. Yeah, this is the ASCII art. Input, which might be for input, vsync. Why do you need vsync in a console? That's weird as well. Frame times maybe. Yeah, we can't see the code yet, but it's quite descriptive what's going on here. Yeah, like 2 bitmaps. Well, bitmaps, ASCII art maps, whatever you call them. The vsync doesn't even seem to be working. Hey, that's actually true. It doesn't seem to work, right? I mean, it's probably more visible even on live coding than it is on my screen. So that's fishy. Like the vsync, very fishy. Okay, and we got back to some obfuscated stuff which we don't really want to look at. So what we could do is actually, one of the things we could do, we could hook this from address thing. because, as I mentioned, after the function is decrypted, then it's executed, and then it's encrypted again. Therefore, for the encryption, well, it needs to be decrypted in memory, so we could probably dump the function at that point, which is also Ambrosia says that zip also. Where did you see zip here? Probably this would be faster. Yeah, where's zip? Oh, next to a vsync. Okay. Well, this is fishy. Let's go this way and let's see what does zip. What is passed to zip anyway? So zip is a built-in function, obviously. So we need to do something like this myzip, and it takes. As you know, zip is actually in Python, it takes two lists, which should be the same size, and it returns a list which basically has tuples of first element of a first list and first element of a second, then another tuple of the second element and second, and so on and so on. So that's actually how zip works in Python. So it's supposed to take two lists in that case. We're going to print them both, and we're going to return zip AB, and then we're going to use the same hack here and change zip to myzip, and this should work nice. Unless it won't work nice, but it should. I hope it does. So let's run it, and obviously it's not working too well because we probably should. What should we do here? We should do save to file. Yeah, this is the code which I was looking for. Can I do rep? Yeah, rep. Sounds good. I think there is this still available in the version of the Python I'm using. So let's just do this. Okay. And I think it's slowed down a little the animation. Did it create the file? Oh, am I overwriting ASDF? I'm not overwriting it though, which is good. I probably should change the name, right? Oh, it didn't write anything to the file, so let's call it XXX. And now the file is not created. Let's maybe input something. Did I run crack me? No, I didn't run crack me. I run okay, thank you. Okay, now let's see. Which is actually lucky. Oh, XX is created now, and it does stuff. Let's break it and let's see what is zip used for. Okay, so it's used for quite a lot of stuff. Okay, I actually changed my mind. What I'm going to do is I'm going to change this to. I'm not going to run rep here. I'm going to do. Yeah, something like this. And the same with B. Yeah, so having you guys actually looking over my shoulder and telling me hey, you're running the wrong stuff, that's actually great. It was pair programming right there. But it's not a pair programming if there are 165 people watching over your shoulder, I guess. I'm going to remove XXX. I have absolutely no idea why I have no alias for that. Okay. And let's see what's there. Okay, so this is funny because these are spaces. Why does it do spaces with something like that? Extreme pair programming, that's a nice name, I like it. My guess, spaces because we didn't enter anything. So let's remove it again. You can actually press F7 and select the command from the menu. It's actually super cool in Windows because if you do the same for Python, open Python and press F7, you have the Python history, which is pretty cool. The history is actually kept in the console emulator in Windows, the history, which is interesting. It's like a different approach, right? Anyway, back to the topic. What I want to do is I want to enter something here, but something meaningful for me. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, maybe without 0. A, B, C, D, A, C, B. Perfect. A, B, C, D, E, F, G. Yeah, the alphabet is hard. Yeah, okay, so I entered like quite a lot of letters, and I'm going to pause it, and I'm going to scroll down. Okay, and let's see what happens here. Actually, like some of the things, we can see like some of the things I put here. I actually should probably copy the string because I'm not even sure I'm like typed the letter in the correct order, and it would be fine if I would like type it later in the correct order and it wouldn't do what's expected. So my guess here that is actually like a comparison. So let's do like this. Let's take these two things. This is repeating, like this is not oh, this is funny. This is like the beginning of a flag, right? So let's take these three things, and I'm going to put them here. And now, okay, now let's do the typing. So let's start from the bottom one. So under the K position, it compares it to N. As my guess, it's comparing, right? I'm going to put some spaces here. So this is N. Then I, it's A. At the G, it's E. So it's like always going to backwards, it seems. I, E, then A at A, and C. Okay, so we have, I guess, some letters. Then this. L is B. Yeah, and again, to back each time. Okay, this is actually making sense. Sorry, where was I? S. MC, right? Okay, so something are like rainbows, maybe? Now, what was known on the CTF and what I should tell you actually here, but maybe I don't have to. This seems to be another comparison, right? But yeah, so 3 is compared to what actually this is misaligned, which I don't like. Let me maybe make this window a little larger. No, I wanted to like put something, but like this is not good. Yeah, this is not good either. Anyway, what was known on the CTF is that the format of the flags was just as we saw, like so D, R, G, and S, which is dragon sector, and then something with an opening curly bracket and some at the end another curly bracket. So we are sure that the first characters are D, R, G, and S, and an opening curly bracket, and then we know there is one at the end. So maybe this is like something MCs are like rainbows. Now, being reverse engineers, we probably can guess that this is like SMCs, which is self-modifying code, which is the term I already used in this crack me during this podcast, right? So let's try this flag. It's just guessing. I'm just guessing with a couple of letters, but I'm sure about the other couple of letters. So let's see if it works. And it is the correct flag. So congratulations to, well, whoever suggested that zip is fishy and whoever noticed that vsync is not even working, because this was the a correct approach to solve this challenge. Now, it might look like a little stretching, right? Because we went like after zip functions which smelled fishy and we got an unencrypted flag, right? And actually during the CTF, at least one team solved it like this, exactly like this. They also found the zip function and said like, this is like, why do you use it anyway? And they did what I just did. So this is actually a legitimate solution. Now, that being said, what would happen if we would actually to go deep into the crack me, and what would we find, and how is how some teams did solve it. I'm not actually going to do it because it would take another hour or two. But what you'd have to do is you'd have to do it like this. First of all, the crackme function, which is like it's obfuscated in the exact same way as it was obfuscated the function I was already analyzing from the beginning of this podcast. It turned out that it's actually a function which creates a set of more functions, and each of these functions obfuscated in exactly the same way. So what you would have to do is you would have to create an automatic de-obfuscator for all these functions and run it on all of them, right? So do exactly basically what we did in the first script, which is here, which is this part, but do it in an automatic fashion for each and every function. Now you would get a lot of functions, and in the end, the password checking was done in a couple of them which were named after graphical functions. I don't know if I can find them right now, but let's look for a vsync one. Yeah, like load font. This is fish, and I believe like part of the flag checking was actually there. And vsync was like just the string where the part of the flag was. So there you have it. This is basically what I shown was the fastest solution, and the team which actually did it was called Delicious Horse, I believe, or Delicious Horses. I believe it was Delicious Horse, and they were the first team to solve this challenge. I don't remember how long did it take them, but it was like way shorter than I expected. So congratulations to them to actually figuring out this method during the CTF. So we actually have about like 20 minutes left of my planned stream. So I'm going to go after another challenge, which was a Linux binary challenge, which was also reverse engineering, and it was, I believe, worth 50 points. So it was like super easy. So there you have it for the Python challenge. And if you have any questions related to the way I solved it, or, well, actually not the way I solved it. If you have any questions related to what I did on the stream, then let me know. Type Kshaku and then type the question. He will tell me that there is a question. Also, if you let me know, like, if you did like what you saw, meaning what do you think about this form. That being said, I need to close these windows and I need to find the challenge somewhere on my hard drive, which shouldn't be that hard. Oh, I can actually show you maybe no. If you would like to do the challenge which I just showed once again, then I'm not going to show you the source code on the stream. You can always download it on my blog. Now, where is my second challenge for today? Okay, I think I found it. It was from the main CTF this time, and it's a Linux one. Yeah, I get it. Okay, it's a Linux one, but as I said, I actually have Linux X server running on my Windows, so I can just run it like natively. Well, natively on a virtual machine, which I have Linux on. But yeah, so I run it, and I actually have like a four monitors, 4 LCD screens, so it by default spans upstairs. Which headphones do I have? I have Sennheiser Momentum 2. Sennheiser Momentum 2. They're really good. I recommend them. They're awesome. Now, this is how it looks like. I actually really like to make my crackmes look cool graphically. Well, to make my crackmes not be like a simple command line thing which asks you for the flag and like just outputs yes or no. So this is how it looks like. Now, what is it? That's the main question actually. So we're going to use file and check what is it. And it's a 64-bit Linux executable which is dynamically linked and is not stripped, which means there are symbols, there are like debugging symbols there. Now the question is, should I use IDA for this or should I use Binary Ninja? I'm actually going to use Binary Ninja. I don't know if you guys know, but Binary Ninja is this like cool upcoming a thing which is actually made by some guys who also play CTFs. If you go to binary.ninja, yeah, you can. I think it's like closed beta right now, but you can chat with them. Maybe they will allow you to enter the beta. I'm going to use this to crack it, because why not? Okay, it says I need to update, but I probably should update. That being said, it's downloading update. Okay, so let's give it a few moments. Product placement. No, it's not product placement. It's like I have a set of tools. This is one of them. So is Binary Ninja better than IDA? No, not by a long shot. That being said, the IDA which you would be able to use with the 64-bit binary is a professional edition, and like the license starts with 800 euros, I believe. So I will tend on my streams not to use IDA too much, just because I am aware that it's like not everyone is able to like go there and buy like IDA for $800 or whatnot. So yeah, Binary Ninja is still being developed, but I kind of like the feel of it. I like where it's going. 85%, so yeah, 95. Let's see what happens when it reaches 100%. Will it just crash my application? Okay, I can click restart. Hey, that's actually neat. Okay, I'm not sure if it did oh, it's updating. There's a window somewhere here. Okay, perfect. EZPZ. Got it. Yeah, this looks nice. So I'm in start right now, and I go to main, and let's see what's up here. It's so actually it doesn't have a decompiler, but it does have. You can actually switch to where was it? You can switch. Sorry, my head is in the place which I'm trying to show you. Here is there are options, and you can switch it to like a low-level language, which is like just a bit higher than assembly, and it's a little easier to read if you're like familiar with C and C++ like languages. So I'm going to be using that because I like it. Usually when I reverse engineer stuff, meaning I actually like have to recompile it for some reason, I also tend to first translate it to something like this, and then to actually C or C++. So what do we have here? We call init window. Again, during reverse engineering, like looking at strings is super important, and it reveals you usually a lot of stuff. So okay, it calls init window, then there's like jump pop, return jump pop. So this is like exiting, I believe. Am I in main? Yes, I'm in main. So okay, so did I ever try to use Kira as a debugger? Yes, some time ago I did try to use it, and it was still like at the early days of Kira, and it wasn't super stable. So I should actually get back to Kira at some point and play with it. It's well, I did see Gerhard use it, right, and Gerhard, and he was super familiar with it because he wrote it, obviously, and super fast with it, and I like the idea how it works. Kind of surprisingly, I actually my bachelor's thesis was on something like that, but that was ages ago. So, and I'm super happy to see someone actually using the concept. It's an obvious concept in the end, right? But to pwn CTF tasks, I should play with it at some point. Okay, so yeah, something jump pop. I'm going to switch. How do I switch actually between them? Do I just press? I just press I. Okay, so let me look in assembly for a second. Then there's an event loop, then there's clock being called, and then draw window is being called. So event loop, I don't know if you have ever written a graphical application, you know, but they're like, and I mean a real-time application like a game or anything like that. You usually have a loop, and there you have like an event loop, which gets input from your keyboard, and then there usually is some logic function which does calculations about logic and graphics maybe. And maybe graphics is like a separate function, and then you have drawing which just flashes the buffer in the end. So what do we have here? Is drawing... It's actually not a library function, and init window is also not a library function. This is probably like... I'm not really going to look at init window. This is probably like a boilerplate code which just creates the window. Okay, there's a question. What do I think about ReRe 2? I tried to use it, and there's like a learning curve, a huge learning curve at the beginning of ReRe 2 where you have to put some hours to actually know the interface. And I put, I don't know, 15 minutes into it, and I couldn't do a lot of basic stuff which I can do like in IDA, or which I did from the beginning in Binary Ninja. Like Binary Ninja has like a super flat learning curve if you used IDA. ReRe 2 doesn't have it, so I probably should take a look at it in the future, but I need to dedicate some time, a couple of hours, to actually get around the interface. I believe the interface was like, designed with the same good user experience principle like Vim, like Blender, like GIMP, which means okay. That being said, I don't know people use it, so it's a useful tool in the end. Okay, so then we have the event loop, and this is a function which does something, and then we have a draw window thing which has a frame, creates an image, writes some text. It has like a draw text thing. Easy peasy. Well, if you wondered if I played CSGO, now you know the answer, right? Then it has like draw animation, which is... well, it looks like bitmap operations. I'm not going to go into it right now. Then it has some draw text. Then, oh, password size and password. This is something which looks interesting, and this is like great work. This is probably, I shouldn't go there yet. So it either draws great work, or what's the alternative? Oh, the alternative is not to draw anything, probably. So, cool. So when is this great work being drawn? Because this is what I'm really interested in, right? Okay, why don't I use IDA for this? That's the question. Again, I could use IDA for it. I have a license which I could use. That being said, I know that some people don't have IDA, which uses which is able to analyze 64-bit code, which is a paid version, is a professional version. So that's why I'm trying to use cheaper tools basically on my streams, and this is what I will try to do on future streams as well. In the end, if everything fails, I'll fall back to IDA, because IDA is the tool to go to in the end if you have enough cash to actually buy it. So again, when is this? When do we go here? We actually check this, and we check if this draw good work flag, it's a byte, right? If it's set to something. Can I do like... I have absolutely no idea how to check other referrers which use the symbol. Can I do something? Oh, wait, it's actually here. It's on my left. That's convenient. So it's even better than IDA, and I would have to click, right? They should pay me for advertisement, I guess. Anyway, verify password. This is something which sounds fun, right? So what's happening here in verify password? We have init MD5. So in one of the things, if you're like starting just with reverse engineering, it's important to note that you have to know that all around you is like chaos of information, and what you need to do is you need to not let it overwhelm you. You need to find only the things which are important or interesting and ignore everything else. So I'm just, as you see, jumping around without analyzing line by line by line by line. Analyzing line by line by line by line is a useful exercise to do. But in the end, after you do it a couple of times, a couple of tens of times, you probably don't have to do it. You probably know what you're looking for already, and I kind of know what I'm looking for already, so I'm looking for strings again. Well, this is a basic challenge, so there are like symbols, so I know the names of the functions, and I know that this is like MD5 init, right? And it takes MD5 context. And then I have MD5 update, and then I have MD5 context again, and then I have finalize. So this is like basically probably the like most basic implementation of MD5. If we go here and if we type RFC MD5, like it's probably the implementation from this. If you open this RFC, right, for MD5, if you jump down, this is the basic code, which follows exactly the same idea, right? So it's MD5 init, update, and finalize, and then there's MD context. So it's probably this implementation in the end. I don't remember if I really used it, because, well, again, this is a challenge I created. So, yeah, so, but it calculates MD5 of something. Now the question is, what does it do with MD5? Because, you know, if it like calculates one hash of MD5 and then tells you like, hey, the password is like 50 letters and you have to guess what password had this MD5 checksum in the end, then it's unsolvable, right? So that would make it a bad challenge. But I'm actually sure this is solvable, so let's just go through this function one by one and see what happens. I'm going to switch again to the intermediate language. So first thing first is it checks if password size. It's if it's 15 hexadecimal, which means wait, how to make it show. Well, never mind. It's what, 21, right? 21 decimal. So it's the question is it like 21 including the null terminator byte, or is it 21 and that's just it? So let's assume it's 21 or 20. It's probably 21 though, because I mean, probably string length is called somewhere and it doesn't count the null terminator. So let's assume the password length is 21. Actually, I should be able to confirm it in a super easy way. Just when we look at this again, I can just count these lines, right? So it's 1, 2, 3, 4. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So okay, we have it correctly. So if that's true, then we have, this is a loop. So it's quite funny because you calculate the MD5, right? But in a loop, why would you even do that? Why do you do it? They do it. I do it. Whatever. Let's see what update is really called with. So, okay, I'm going to switch back to assembly, and now actually to understand what parameters are being passed to update, I need two things, and that is the calling convention. So I actually know the calling convention. You probably know as well if you reverse engineer stuff on Linux, but I'm going to show you an awesome document which has a nice list of calling conventions. There's a person called Agner Fogg, and there's a calling conventions document he maintains. He actually has quite a lot of awesome stuff. And this document, it's great. I really recommend you looking at it if you're into reverse engineering. It has like a lot of good things, like calling conventions for everything. What are the like Collie preserved registers? What are the scratch registers for different systems, and so on and so on? What are different sizes of different variables and different compilers? What goes on stack? What goes to what register? It's super awesome. Now, register usage is what I'm interested in, and it's 64-bit Linux, right? And registers for parameter transfer, and this is it. Which means first argument of the call will go to RDI, then RSI, then RDX. So really, this document is awesome. Read it, look at it. Even if you're experienced, you might find some really cool snippets there. Thanks, Shaku, for pasting the link around. Now, so RDI, which is the context, probably, right? I mean, init context is called on it, so it's on the same address, like var A8. Then ESHI has the password, which is the buffer containing the letters you probably typed in. And then we have this is what is it? This is used here, so never mind. RDX was the last thing, if I remember correctly, and there is just AEX, and it puts some variable from BC there. What's BC? Oh, it's initialized to 0 at the beginning, right? So it's initialized to 0 here, and then they add 1 to it. And this is a loop, right? So it's like, it starts with 0, then they add 1, so it's in the first iteration of loop it's 1, then it's in the second iteration it's 2, then 3, then 4, then 5, and so on, which means you first actually calculate the MD5 of just one character, and then you calculate of 2 characters, 3 characters, 4 characters, 5 characters, and so on, which actually means that it's well, it's quite easy to solve this challenge. Now, Kshaku says there's another question. Can you still subscribe to beta of Binary Ninja? Actually, you never could subscribe, but you can contact the guys and ask them, because it's closed beta. It's closed beta, so you have to ask them politely, and maybe they will say yes. Yeah. Okay, there's another question, and it's, did I see this? I think I know what this is, but let me open it. It's Reverse Engineering for the Beginners. It's the open source book, or the free book, if I remember correctly. Yes, I did see it, and I actually did recommend it in a couple of places. I didn't read it because I somewhat know already how to reverse engineer, but as far as like having everything about reverse engineering in one place goes, then this is a nice place. Like, it's 1,000 pages basically worth of knowledge about reverse engineering different stuff. So yeah, it's worth looking into if you're just starting with reverse engineering. Sorry, I need some tea. Sweet. So there's another question, like what happens? Oh, good hashes. Yeah, I was like going to ask, where are the good hashes which are being compared to? Where do they come from, right? And here's the answer. They are coming from this place, which means that each 16 bytes, because like MD5 is actually 128 bits, which means 16 bytes, is one hash. So I should just copy 21 times 16 bytes from here and see what hashes these are. I'm going to copy maybe a lot more memory. Oh, I can copy as, and I want to copy this as escaped ANSI string. Perfect. This is exactly what I need. Now I'm going to create a new file, which is go.py. This is usually how I call my scripts in Python. I prefer Python to for my scripts during CTFs. It actually separated the line, splitted the line for me, which I don't like. Okay, and I call it just hashes, and you know what? I'm actually going to put it in another file. Okay, and I'm going to do from h import hashes. Just, again, not to have like a huge line in Vim, it kind of annoys me. Okay, there's a question. How did you get Python to autocomplete in Vim? Actually, I'm using the default autocompleting in Vim, which means it is like language agnostic, but what it completes with is actually the stuff which is already in a file. So if I type I and press tab now, it says import, but it will not say anything else because there is no other word in Vim starting with I at the beginning. So basically that's it. It's just like basic auto-completion, nothing magical, no content awareness at all, but it's fast. And what I like about my editors is actually them being fast. Okay, I said the stream is going to be 2 hours, so I need to finish this quickly, and we can finish the stream. But first we need to get the flag, right? So what do we do? Let's do something like this. Import MD5. There's both like MD5 and MD5 and hashlib MD5 in Python. I don't really care. Let me do hashes 0 to 16 and encode this as hex. This is why I prefer Python 2 actually over Python 3. In Python 3, you can't really do stuff like this with you know, base 64, zlib, and so on because of a couple of reasons. It's a little more complicated. You have to use codecs. Now in Python 2 you can still do it, so this works for me. Now let's just run it and see what's the hash. This is the first hash, and I'm going to just look it, like Google it up. And according to md5cracker.org, which is a random site, it's D, which is okay, right? Because it's the same, like, again, it was our CTF, so it's like the dragon sector at the beginning, DGRNS, yeah. So, this is actually good. What I'm going to do here is going to do, like, brute force one by one. So I'm going to, like, implement a super simple byte by byte brute forcer. And I already know there are, like, 21 lines. Now I start with an empty string. And, okay. Now I do this. Actually, that's stupid. I'm going to do something like this. Whatever. Doesn't matter. No, I actually do need I. Now I convinced myself that I do need I. So this is the correct hash, which is obviously I do I times 16, and here I plus 1 times 16, which means I just grab the hash, right, the bytes there. Now what I do is I need to brute force it, so I'm not going to go obviously over the whole character set. I'm just going to go from a space, right, some 32, which is like basically a space, to 126th, because that's the last printable character in ASCII. And then I'm going to do something like this. My test will be s plus character of given character code, and I need to check if md5 of this test is equal to digest. I don't know if you say digest or digest, actually no idea. If this is correct, then I add the character. I'm actually going to make it like this, and I do break. Otherwise, if it, yeah, I don't know, let's assume it just works. And I'm going to do even one more thing here. I'm going to print s. Now, I'm not going to flash anything like flash standard output, because if the terminal is attached by default, then standard output is being flashed with each new line, and print adds a new line, which is exactly what I want. So I'm going to do this. Blah, blah, blah. And this is not well. Yeah, so good. Module object is not callable, obviously. Yeah, okay. And we have this, which is the flag, probably. Let's just try it. So it's stars and stones. And let's see if it works. Dragon sector. Great work, it works. So this is the correct flag, and this is the solution to this task. Random question: does anyone know from which book is the quote "stars and stones"? I know that my moderator knows, but I'm wondering if anyone else knows. Yeah, so Ambrosi says that you can use like bin ASCII library, which is correct, but that being said, it's not really you know, sorry, it's not as convenient to import another module and call bin to ASCII something when instead of like just doing .decode something, which is a little more convenient in my opinion. Anyway, the quote is from Dresden Files, which is a book my moderator Kraku recommended, and it's super awesome. Anyway, that's actually all I had today to show you. So we actually managed to solve both crack me's, which I consider to be super awesome. Please let me know, like, both on chat, maybe using email or in the comments on YouTube if you're watching it after, like just the recording after the live stream. What do you think about it? Do you want more live streams like this, or maybe you say that like it might have been a good idea but it didn't work out, the execution was poor or whatever. So if you have any comments, then just let me know. And that's actually it. So thank you again to Kshaku for being the moderator on chat. Thank you for tuning in to everyone of like 170 people, I believe, at the peak rate, maybe even 200. So thank you. And see you probably, if you liked the idea, then see you next week. And I'll have some other challenges prepared or some other thing to hack on. Otherwise, that's it, and I leave you with some music and like end credits or whatever. So thank you and see you around.